Good morning, everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is Hampeyo Kliman, the mentor. So today we are going to be finding the domain and range of composite functions. Okay, and then we are also going to do questions, and we also do a lesson on equality of two functions. I like questions about composite functions. Why? Because a composite function is simply a function in a function, and that makes it interesting. Let's get started. We have a question that's saying let g of x be this equation x to the power 2 minus 4 and h of x equal to the root of x. We find g is equal h being evaluated at some point x and its domain and range. All right, so let's solve the first one. B saying we find h of h is equal g being evaluated at some point x and its domain and range. All right, so now how do we solve such a question? So the first one, we have been given g of x to be x to the power 2 minus 4, and then we have been given our h of x to be the root of x, and then we have been told to find g is equal h. Okay, so we are finding g is equal h. Okay, g is equal h being evaluated at some point x. So now this simply means that we are getting the function of g, and then inside the function of g we are going to put the function of h. So I'm going to get this particular equation. Okay, I'll get this equation, then where there is x, I'm going to put my h of x. So this is going to be my h of x power 2 minus 4. And then when I solve this, I'm going to get x minus 4, okay, as my g is equal h, okay, being evaluated at some point x. Now, what is the domain of this particular function? Notice that x minus 4 is a polynomial function. It is an equation. Henceforth, its domain is going to range all the way from negative infinity to positive infinity. That is the answer. Okay? What about its range? How is the range going to be like? The range for a polynomial function of this particular type is also going to come all the way from negative infinity to positive infinity. Okay, so that is just how you solve the first one. We get to solve B. B is saying h is equal g being evaluated at some point x. We find the domain and the range. So we are finding h is equal g being evaluated at some point x. So we are getting the function of h, which is this particular guy. Okay, so we get that particular function, and then inside this particular function we put the function of g. So I'm going to get my g. So this is going to be the square root of, this is going to be x power 2 minus 4. So we have a radical. What do we do? How do we find the domain of a radical? Well, we just equate what we have. So this is going to be x to the power 2 minus 4. Then we say greater than or equal to 0. Then I can use the difference of two squares I'm going to get x minus 2 and then x plus 2, everything greater than or equal to 0. Then after this, I know that I'm going to get something like x is going to be greater than or equal to 2, and then x is going to be greater than or equal to negative 2. So how is the domain going to be like? So now, whenever you find something like this, you need to test your values. So I'm going to test these values. Okay, so I'm going to have a set of this particular type. I'm going to test these values on a real line. Let me test them. I see where my domain is going to start from. So I have negative infinity, and then I'm going to have my positive infinity, and then I'm going to get my negative 2 here, and then I have my 2 here. Okay, so now I'm going to have a set from this particular point. Okay, from this particular point, it's going to be a set from here. I'm going to have an open circle here, and then I'm going to have a crossed circle here, and then I'm also going to have a set, okay, from 2 cross circle all the way to 2, a cross circle here, and then I'm also going to have a cross circle here, and then I'm going to have an open circle at positive infinity. Then I'm going to test this set of values. Now notice that from negative infinity to negative 2, I can pick a value here. Okay, I can say, let me get negative 3, okay, as a set point. Then in between negative 2 and 2, I can say, let me pick negative 1. Then here I can pick any value, okay, from 2 to positive infinity. I can say I pick 3. Then I'll test my values using this guy. So okay, so this is going to be my test one. So where there is x, if I put negative 3, then I say minus 2, and then negative 3 plus 2, is it going to be greater than 0? So notice that this is going to be negative 5. Okay, this is going to be negative 1. Okay, it should be greater than 0. Negative 5 multiplied by negative 1 is going to give me 5. Is 5 greater than 0? Yes. Henceforth, this region from negative infinity to negative 2 is true. If I put negative 1 where there is x, as I'm using this set point, and then negative 2, and then here I put negative 3 plus, sorry, negative 1 plus 2, is it going to be greater than 0? So this is going to be negative 3, and then here we're going to have a 1. So negative 3 multiplied by 1 is negative 3. Is negative 3 greater than 0? It's not holding. Henceforth, from negative 2 to 2, it's a false region. So this is a false region, okay? But if we get any number from 2, between 2 and positive infinity, if we put it in this function, it is going to prove correct. You can test that. Henceforth, the domain for this particular guy is going to be a set from negative infinity to negative 2, included, union of 2 included to positive infinity. How is the range going to be like? Notice that if I get these two set points, 2 and negative 2, if I put them in this function, if I put 2 where there is x, I'm getting a 0. If I put negative 2 where there is this function, where there is x, I'm still getting a 0. So when I use my two set points, -2 and 2, the lowest number that I'm getting is 0. Henceforth, my range is going to come from all the way from 0 to positive infinity. That is just how you solve the first question. We get to the second. Okay, so we are done with this. Let's solve 2. 2 is saying find the domain of the following composite functions. So the first composite function that we are solving the second question. Okay, so we have something like f of x is equals to x plus 2. So our f of x is equal to x plus 2. And then the other function is g of x plus 5. So g of x is equal to the radical of x plus 5. Okay, so how do you solve this particular question? It's very simple. The first one, they are saying we find this particular operation, which is f plus y being evaluated at some point. So we are finding f plus y being evaluated at some point x. So this simply means we're getting to add everything. So this is going to be x plus 2 and then plus the radical, which is x plus 5. Now notice that this part here is a polynomial, so its domain is going to come from all the way from negative infinity to positive infinity. This guy is a radical, so how do we find the domain of radicals? We say root of x plus 5. Okay, so we are going to get whatsoever is inside. We say x plus 5 must be greater than or equal to 0. Then x must be greater than or equal to -5, like that. So we can plot that on the real line. It's going to be like this. So it's going to come all the way from negative infinity to positive infinity. Then we have a -5. Now notice that for the first domain, for this guy here, who is a polynomial, we are coming from an open circle at negative infinity all the way to an open circle at positive infinity. And then for this one, we have an open circle at 5, and then it should be greater than or equal to -5. So we are going to positive infinity, like this. We have an open circle here. So where are they meeting? They are meeting at this particular point, at this region. Henceforth, our domain for everything is going to come all the way from -5 included to positive infinity. That is just how you find the domain for this particular function. Okay. B saying we have the function of f of x. This function of f of x. Okay, so we're calculating B. They are saying we have the function of f of x equal to, what do we have? X plus 3. So this is going to be x plus 3. And then we have another function, which is g of x, which is x plus 2. So g of x is equal to x plus 2. And then we have been told to find the range and domain of this particular function, but under which operation? The operation is f over g. Okay, the operation is f over g being evaluated at some point x. So this simply means we are getting the function. So f over g is simply this function. So we have this function. How do we find the domain of this function? We are going to get the denominator, and we must say that it must not equal 0. So this is going to be x must not equal -2. Okay, henceforth its domain is going to range all the way from negative infinity to -2, not included, the union of -2, not included, to positive infinity. That is how we find this particular question. How do we find the range? To find the range, we are going to say that where there is f over g, we are going to replace with y. I think in the video I had shown how to solve this, if you follow me. This is x plus 3. Okay, so this is going to be x plus 3 over x plus 2. So I'll cross multiply and I'm going to get my y, x plus 2 equal to x plus 3. So this is going to be yx. If I expand everything, then this is 2y equal to x plus 3. And then I want to make x the subject, so I'm going to get all the x to the left hand side, and my -2y on the other side, plus 3. Then I can factor out x. I'm going to have y minus 1, and on the other side this is going to be -2y plus 3, all over by y minus 1, all over by y minus 1. So I can say that this is going to be x equal to -2y plus 3, everything y minus 1. So I can do the same to find the range. I'll say that y minus 1 must not equal 0. So y must not equal 1. Henceforth, the range is going to be a set from -infinity all the way to 1, the union of 1 to positive infinity. That is just how you solve this particular question. Okay, let's get to solve 3. 3 is saying we find the domain and range of the following function. Okay, so we have f of x. Let me just clear my board. Okay, so I clear the board. All right. So what do we have? They are saying we have the function of f of x. So the function of f of x is going to be the set 3x minus 12. And then we have g of x equal to root of x. Let me check if what I'm okay. And then we have been told to find f sec g. Okay, so this is the first function that we're doing. F sec g being evaluated at some point x. How do you go about this question? So we are simply getting the function of f of x. Then while there is x, I'm going to replace with my radical. This is very simple. So to find my domain, I'm going to equate root of x, okay? Root of x, then I just pick my x and say x must be greater than or equal to 0, okay? Henceforth, my domain is going to be a set from 0 all the way to positive infinity. How is my range going to be like? So for this one, you don't even have to panic. Just get this value. Henceforth, my range is going to be all the way from -12 included to positive infinity. Okay. So if you want to put this one in set beta notation, you can say that this is going to be a set y is such that y must be greater than or equal to negative 12. At the same time, y must be a member of all real numbers. That is how we write it in set tutor notation. It's very simple. You can apply the same concept to all. We've solved the first one. How do we solve g of x? So the second operation is g, the function of x, inside like that. So we get the radical. Where there is x, I'm going to put this value. Of course, how do you find the domain? We get 3x minus 12 and say it must be greater than or equal to 0. So this is going to be 3x greater than or equal to 12. Then all over by 3, all over by 3. This is going to be x greater than or equal to 4. So my domain is going to be a set coming from 4 going all the way to positive infinity. How do you find the domain? How do you find the domain? Sorry, the range. How is the range going to be like? Notice that 4 is a set point value. If I put 4, let me do some proof. If I get 4, if I get this particular function, then when there is x, I put my 4. Notice that if I put 4 here minus 12, I'm going to get something like 12 minus 12, which is going to give me a radical of 0, which is going to give me 0. So 0 is the smallest value that we can only put in the radical and it defines the function. Anything less than 0, there's no negative, there's no radical of a negative number. It will give you undefined. So 0 is the smallest number. Henceforth, the range is going to start from 0 all the way to positive infinity. That is just how you come up with the range and the domain for this particular function. It's quite easy. All right, we get to 4. How do we solve question 4? How do we solve question 4? Okay, so to find question 4, we have been given this particular equation. They're saying find the domain of f circle g where f of x. Okay, so our f of x is a set 3 over x plus 2, and then our g of x is a set 4 over x. So for this one, they are saying we find the domain of f circle g. So we are finding the domain of f circle g being evaluated at some point x. So to find this, let me go back. Okay, so what we are going to do is this. What there is the function of, for this one, what there is the function of f of x inside, you are going to put this particular function. Okay, so let me just give you a picture of everything. This is the function that you are going to have. So you are going to have 4 over x here and then plus 2. Now I don't need to solve this. I just need to find the domain for this particular guy, so that if I get a value from that domain of x, I put it here, it should not undefine this function. Okay, it should not undefine the function. So now what I'm going to do, so first of all, I'm going to solve the domain of this guy and the domain of this guy. So f of x is equal to 3 over x plus 2. So x plus 2 must not equal 0, then x must not equal negative 2. So I'm getting a domain which is going to come from all the way from negative infinity to 2, and then from union of negative 2 all the way to positive infinity. Okay, that is for this particular set operation, the first one. So for g of x, I have 4 over x. I'm going to say that my x must not equal 0. So already, if I put this guy into f of x, these are the values that I should never have, because if I have these values, I am going to undefine the function. Okay, so if I combine everything, I would say that, okay, so I'm going to put it in other terms, other mathematical terms, that is set grid notation, if I want. Okay, so I would say the domain, okay, I'm going to write it like this, is going to come all the way from negative infinity to negative 2, union of from 0 to positive infinity. That is one language. In other terms, I'm going to say the range is going to come all the way from, is a set such that y is a set such that y must not equal negative 2. Sorry, this is supposed to be the range. So this is going to be the domain. In other terms, is going to be x is such that x must not equal negative 2, and then x must not equal 0, but x must be a member of all real numbers. That is just how you write everything in set grid notation. And this is very much true, because within the range of these set values is going to undefine the function. Okay, any other thing is very much okay. All right, we have question 5. Question 5 is saying we determine whether f and g are equal functions. So we are dealing with what we call equality of functions. When are two functions equal? Two functions are equal if f input of A equals to g input of A. So we'll be using this concept. So the first one that we have is, they're saying we prove that f of x plus f of x to the power 2, then this g equal to that. So we have our f of x equal to, this is going to be x to the power 2 plus 2, and then we have g of x equal to, this is going to be x plus 2 power 2. How do we prove that this is equal? Is this equal or not? So I'm going to say that for this to be equal, then f input of A must equal g input of A. I will let my A equal to, so I'm going to say x power 2 plus 2 must equal x plus 2 power 2. So I'll put my 2 where there is this guy, and then I can put 2 here, and then I'm going to have a 4 plus 2. Here I'm going to have a 4 power 2. So this is going to be 6, this is going to be 16. This does not hold, henceforth f of x is not equal g of x. We get to B. So B, we use the same concept. Where is it? Okay, so we have f of x like that. Okay, so for this one we have our f of x equal to x power 2. G of x is the absolute value of x power 2. So now for this one, the same concept applies. F input of A must equal to G input of A. I can say I let A equal to 2. So this is going to be x power 2 equal to the absolute value of this. If I put 2 here and then I put the absolute value here, so this is going to be 4. The absolute value is a machine that makes anything negative positive, but of positive value it makes it positive. It will still stand. So this is just the same as positive 2. 2 to the power 2, it is 4. So this is an equal function. So I would say f of x is equal to g of x. Let me clear my board. Okay. Let's do the last question. Let me just grab my board. Hope you are able to understand and apply these simple concepts in your work. So the last question was saying, okay, so we have that. We have this particular function. Okay, and then this function we have been told that it is x to the power 2 minus, okay, so x power 2 minus 1 over x minus 1. Let me check if this is correct. Okay, so this is okay, so this is positive 1. G of x is equal to, let me see what's there. Okay, so this is going to be x minus 1. So I can use difference of two squares. Okay, so this is going to be x plus 1, x minus 1, x plus 1. G of x is equal to x minus 1. That guy and that guy can cancel. F of x is equal to x minus 1. Okay, g of x is equal to x minus 1. Notice that even before I put the values, f input of a is going to equal g input of a. If I let my a equal to, let's say, a set point value 2, then x minus 1 is going to equal to x minus 1. So this is going to be 2 minus 1 equal to 2 minus 1, and I'm going to get a 1 equal to a 1. This proves that f input of a is equal to g input of a for this particular equation. Henceforth, this equation is equal. The first equation wasn't equal, the other equations were very much equal. This is just how you solve these particular equations. If you understood this video and you like the video, consider subscribing and also hitting the like button. And also, if you want to join my academy, Hamper Kleeman Online Academy, consider unboxing and also commenting or following the video, and I'll be able to access you. Thank you so much.